Recording. All right, welcome. I apologize for Tuesday. Although what I have to remember is I always feel terrible when I have to cancel class, and I rarely do cancel class. But then I have to remember that as a student, I used to love when class was canceled. So anyways, my apologies, but hopefully you were able to find something to do in that time. And I am feeling better, but I just taught a class, so we'll see how my see how my voice holds up. Yeah, I was trying to talk on the Monday night, and I couldn't really talk without breaking into a coughing fit. So that makes it hard. So thank you. I'm happy to be back. Okay, so I updated the link, although you guys were really good. Oh, whoops. You guys were really good about finding the textbook anyways, but I did, thank you. I did update the link just in case. So if you follow the textbook link, if you don't want to get a hard copy, I've ordered mine, but it's still not here. So I'm so curious. Is it big? Is it small? I can't wait. But if we go through that link, then it should just take you straight to the page so you don't have to search for it anymore. I hope that works on your end as well, and not just my end. So if you try that link, then you should be able to click here to access OC students and employees only, and it should just take you to the textbook. And I think it remembers where you were in the textbook. Okay, and so what I want to do is last week I kind of wanted to remind you of everything that we did in Stat 230 and go a little bit deeper into regression than we were able to do because we didn't really have time. So I just wanted to kind of feel like I wrapped up Stat 230 appropriately, and we will come back to regression and we will come back to hypothesis testing. So that's not the end of it, but I did want to feel like we kind of had a good end to it. Okay, and so now what I want to do, and I had to take that time to find a textbook for us. And so now what I want to do is I want to get into our textbook. Okay, and so of course, this is just statistics, but from a different angle. Okay, so it's with a focus on data science, which is really nice. But I also am finding that as I'm reading the textbook, it's really good that you have had, that you've seen a lot of these concepts already, right? Because sometimes I feel like they do not a great job of it at explaining stuff. And so, for example, they mention the normal distribution in chapter 1, but they never actually say what it is. So some of that knowledge is kind of implied. So I think we're in a good position to start reading this textbook, and that's what I want to do. So I'm going to work in this textbook, and today I'm going to get into, where am I here? I'm going to get into chapter 1, okay? And a lot of chapter 1 is, well, it's all review, okay? But what we're going to find is that, okay, well, they kind of focus on some other things. And the main difference from Stat 230 to now is that we're not going to do anything by hand anymore. That's crazy. We're going to use software. In fact, we're going to use R and Python as much as possible. Okay, and what that's going to do is it's going to show you, okay, I can do it in R, And that's going to be my emphasis, right? Can you do it in R? And then showing you how to do it in Python. Sometimes you might say, well, I prefer to do it in Python. That's fine, right? Or you might say, oh, okay, that was a little bit easier in R, and then you have options, right? And so being able to do do the same thing in two different software programming languages, I guess, is a good thing. Okay, and so I'm going to save the programming aspect for the lab for this week. And what I want to do is I'm going to start in RStudio Cloud in the lab. And if you haven't used RStudio Cloud, it is all set up, so you don't have to do any installation. So if you're getting frustrated with the installation, that's not part of it, right? I'll show you how to do it, but that's not part of what we're working on here. The part that I'm interested in is doing things in R, doing things in Python, and seeing the same thing. Okay, so none of these concepts should be that strange to you. There might be some things that we didn't emphasize in Stat 230 that we're going to emphasize a little bit more now, but in general, we're going to talk about, so chapter 1 is on exploratory data analysis. So just all the things that we would look at when we're handed a data set. Okay. What I want for next week is I want you to read chapters 1 and 2. Okay. Again, chapter 1, you have all the concepts. I think it's really nice how they introduce some of the concepts, especially things like terminology. Okay. They do a good job of reintroducing terminology. Okay, so for next week, oops, please read chapters 1 and 2 of the textbook. Oh, and you can tell, well, I wish it was maybe my illness. Maybe it was just me being disorganized, but I forgot to put a Dropbox up for lab 1. So I've posted that, and that's where you'll have to submit your lab 1. January 30th, I think so. Lab 1, when did I make it due? Couldn't tell you. Sunday, probably. Is that when I made it due? Let me check here. Lab 1 submission. I have one already. January 30th. Yeah, perfect. Thank you. So lab number 1 is due Sunday, January 30th at 11:59 p.m. Nice. Okay. And I mean, nothing crazy going on in lab 1. We're just kind of getting warmed up, and I think I gave you a little baby exercise to do. Okay, and so for the lab this week, we're going to be relying on the code that's in the textbook and just kind of sussing out, okay, the difference between R code and Python code. And then I'm going to go let you fly free. But I'll save that for tomorrow. Okay. And again, the labs are just videos. Okay, so we're not meeting live because Friday afternoons, no. You've got better things to do probably. Okay, so and with a little bit of luck, I'll be able to record it today, but it kind of depends on my throat. Oh, the lab videos are just in our on our YouTube playlist. So I just incorporate them with the playlist. And I did notice that I had, or YouTube was kind of holding my videos. It wasn't posting them. They were marked as pending. And so then eventually I had to take it down and re-upload it, and then it would work. So I don't know what happened there, but they should be, there's this link to the lecture videos, and that's also the lab videos. Okay. Good. So lab number 1 is due on Sunday. Okay. And then lab number 2 will be due the following Sunday. And so the labs will always be due. You'll have a week, and then the Sunday night is when they'll be due. Okay. Okay. So today, I feel like there was, oh, you didn't find the lab 1 video. Let's see here. What does it look like? It's there. Stat 240 lab 1. So it should be there. Okay. Good. Sorry, I'm realizing it's a direct message, so not everyone's clued in here, but the question, they couldn't find the lab video, but it should be there. I see it, so hopefully it's there. Oh yeah, I keep feeling like there's one more administrative thing that I should be doing that I can't quite put my finger on, so let's just get started. So chapter 1 is on exploratory data analysis. One thing that I will say, so now that I've asked you to read chapters 1 and 2, those are fair game now, right? So in terms of testing and for lab work and stuff like that, I am assuming that you have read these chapters, not for today, obviously, because I just asked you to do it, but for future classes, right? I am assuming, because we can't talk about everything that's in the textbook, right? And they do talk about some really kind of cool things and fun things, fun to know things. And they have lots of references, which I know can be kind of tedious in the beginning, but sometimes they're really interesting, right? And so, so kind of from next week on, I am assuming that you're reading the textbook, because I know we talked about this before, where we said, okay, just my notes for now until I find a textbook. But now I've found a textbook, and now that's all fair game. Okay, so so I am going to assume that you've read all these for next week, okay, and keep up with your readings. One thing that I want to say about readings is I want you to do it because I want the time that I tell you something, I want it to be the second time that you hear something, or ideally the third time that you hear something, because that's when it starts to make sense. You can't expect to read something and then just understand it immediately, right? It's not until the second or the third time that you hear it that it's going to start to make sense. Okay, so you need to expose yourself, right? So you need to actually read through it, even if it doesn't really make sense. You try your best and you read through it, and then when you come to class, then hopefully when I talk about stuff, it kind of starts to fill in some gaps, right? And then things become smoother as you go. Okay, so just keep that in mind. I know reading is tedious. No one likes to do it. I'm sure there's videos out there. I have no clue, but I prefer to read. So I don't know. I'm weird that way. A lot of people prefer videos, but I prefer to read. Okay. Chapter 1 is on exploratory data analysis. Now, I don't typically call it EDA, but you can call it EDA, exploratory data analysis. It's basically the first thing that you should do once you're handed a data set, right? So once we have a data set in our little hands, right, then we need to go exploring, right? What can we find? What can we learn about this data, right? And so we're going to take it from the top, and this is going to feel like deja vu, and it is deja vu from Stat 230, right? But now I'm going to try to kind of highlight the differences. Okay, so exploratory data analysis is the first thing we do when we are first handed a data set, right? So usually as data scientists, you're not going to be collecting any data. Often you'll be handed data, right? And so your first thing is to get acquainted. What's going on in here, right? So the first thing we do when we have been handed a new data set. Okay. And the goal is to get to know the data, right? The goal is to get to know the data. Yeah. What types of variables do I have? Which would then put me on the path of what's appropriate for me to do here, right? And so just knowing what types of variables you have is going to kind of cut a path for you in terms of your analyses. One thing that we're not going to talk about here is cleaning our data. Okay, so we are going to kind of assume that we have relatively clean data. And what I mean by clean data is, we've dealt with missing values. All our data is rectangular, which we'll talk about, but it's exactly what it sounds like. It's in kind of a spreadsheet, nice format. And so there are a couple of things that we're assuming that we have already. Okay, and we're not going to focus so much on cleaning the data but that's a big part of it too, right? So we're going to kind of skip past that. And what's going to happen is that's going to come just through practice, right? Because what you're going to find is that you're going to know what your data should look like to do your analyses, and then you just kind of make that happen. Okay, so that's going to depend on your analyses, and we'll kind of see more of that as we go. But okay, so exploratory data analysis is basically like a get to know you period of your data set. So some things that we do, we run numerical summaries, and we also tend to visualize the data, right? And so some of the things that we do are we consider numerical summaries, and also we visualize the data. Okay. So this is all exploratory data analysis. And often we are kind of led down the path of, okay, that's something interesting that I want to look at later, right? Or maybe there's something going on there that I'm going to look into a little bit later. Okay. Now, depending on if we have numerical variables or categorical variables, that's going to determine how we can summarize or visualize these variables, right? And so that's going to be our first step, right? And again, this is all kind of a repeat, But what I really like about the textbook so far, and I mean, I just decided on it, so I haven't read it, of course, but in its entirety. But what I like so far is they really highlight all the different terminology that we can use. Okay, and they also kind of highlight, okay, so in statistics, we use this term, whereas now in data science, we tend to use this term. And I'm going to try to highlight those as much as I can, especially where the terms are different from what we used in Stat 230, right? And so, I'm going to try to do that. No new concepts, just new terminology for the same concepts. Very confusing. So our goal is to get to know the data. Okay? And so our data types that we have, which we were calling variables before, okay, can be split into two, I don't want to say categories, but they are categories, right? And so we can have, I call it numerical, but they call it numeric. So I'm going to try to stick to that. Of course, you can be flexible and you can kind of be okay with either one. But they do call it categorical, which is exactly what I call it. Okay. So we've got these two main data types that we can consider, and any variable that we have can be put into one of these groups. Okay? And so what we're going to do is we're now going to distinguish a little bit further between the numeric and the categorical variable. So a numeric variable can be continuous. Oops, let's see here. Or it can be discrete. Okay. So a continuous variable is something on a continuous scale. So if you think about, okay, the tool that we measure things in, could it be more precise, right? Are we just limited by the tool? So for example, I think, most speedometers only go to, or they work in whole numbers, but of course our speed is continuous, right, for cars. Or for a discrete number, such as age, right, it gets confusing because we typically only say, okay, I'm 35 years old. I think I'm 35. That's okay. Yeah, I'm 35. Anyways, so I'm 35 years old, and some months and some days and whatever, right? And so, right, but we only talk about the whole number, and so that's what would make me consider it discrete, even though of course, age is a continuous thing. If we talk about it, if we only talk about it in whole numbers or to some set number of decimal places, then we would consider it discrete. Okay, so so kind of tricky. For the most part, we're not going to distinguish too much between continuous and discrete variables. So I'll kind of parking lot that here. Okay. Whereas for categorical variables, usually what I do is usually I say that a categorical variable can be split into either nominal, so having no natural ordering, or ordinal, where there is some natural ordering. Now, because binary data is so is kind of its own thing here, we're going to pull it out as a specific or a special kind of categorical variable. So here, binary data, which is when we have kind of 0, 0, 1 data, that's binary data. So there are only two categories. Whereas the other categorical variable that we could have is ordinal, okay? Meaning there's some natural ordering. Has natural ordering. So the categories have some sort of natural ordering. For example, what year of school are you in? First year, second year, third year, fourth year, fifth year, victory lap, right? So on and so forth. And so there we have some natural ordering, right? How much money do you make, right? Then there would be money categories. So notice there are many times where we convert a numeric variable into a categorical variable, but we can't go the other way, right? So once we've converted a numeric variable to a categorical variable, we've lost that individuality, right? Now we only have categories. But for example, income, we could create categories and then we could create this categorical variable. So one thing to note, we often convert numeric variables. Oh, I'm used to calling them numerical variables, but I think I'll try to call them numeric to match the textbook here. Numeric variables into categorical variables. That is, or maybe for example, rather. For example, income categories or income brackets. So although we can go from numeric to categorical, we can't go the other way around, right? So once we have our data as categories, then we can't go back unless we've saved the individual information, right? But it is not possible to convert a categorical variable into a numerical variable. Yeah. So if we go back to our categorical variables, right? If I have an ordinal variable, then it has some natural ordering, and you might remember that the other option was nominal, right? And so here, what we're saying is a categorical variable is by default a nominal variable, meaning there's no ordering. So if we don't specify, then it's the nominal variable, but we'll just call it categorical now. Okay, and so if you have a categorical variable, then now we're going to focus on binary versus ordinal data. Now, ordinal data, right, has that natural ordering. Okay, on a scale of 1 to 5, how do you feel about something? So survey data, right? So here, on a scale of 1 to 5, right? That would be ordinal data. Those are categories. Just because you're using numbers, and this is what trips people up a lot of the time, is that just because we're using numbers doesn't make it numeric, right? We often use numbers to be placeholders for categories. Okay? So here, I'll kind of make a note down here. Note, all these notes. We often use numbers as placeholders or indicators in categorical data. Exactly. So phone numbers, for example, might trip you up, right? But those are categorical data. Now, you would probably only look at the first 6 digits, for example, not all the digits because they're all unique, right? But we might look at the first 6 digits. Exactly. So just because there's numbers doesn't make it numerical, right? We have to dig a little bit deeper. And so I feel like there was something else I wanted to say here, but we often use numbers as placeholders or indicators in categorical data, right? So be careful when determining whether a variable is numeric versus categorical. All right. So that happens a lot where we use these numbers, but we don't want to treat them as numbers. They're just placeholders, right? Talking a bit about binary data, we didn't get to talk a lot about binary data. We did a little bit, but not a lot, not enough in Stat 230. So and one big field that we're going to consider, which is logistic regression, is trying to predict when we have a one outcome. Okay, so we're going to focus on binary data. So a lot of our analyses for categorical data is going to be for binary data. Okay. So a lot of the analyses that we do for categorical data is focused on binary data. So a lot of the analyses we consider for categorical data is specifically for binary data. Is specifically for binary data. How can that be? If we have categories, right? Then even if we have, let's say, 4 categories, right? Then there must be one category that we're interested in. Okay? And so the reason for that, the reason is that any categorical variable could be converted to a binary variable, right? And so the reason is that any categorical variable can be converted to a binary variable. Okay. So for example, on a scale of, on a scale of 1 to 5, right? Blah, 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 blah. So now my categories are what? 1, maybe strongly disagree. Disagree, neutral, agree, strongly agree. 2, 3, 4, 5. Okay. One side note, if you're making a survey, because it's kind of where I came from in industry is making surveys. So one thing that you would want to remember is that the order that you present these, because people don't read, no one reads. And so sometimes, even if they meant to pick strongly agree, they might pick number one because it's the first one, right? So just be careful with how you present the options, because that can also yield bias in your survey. But anyways, let's ignore that. But I just wanted to make a note of that because that is really important. And now hopefully you'll pay attention to that when you do your next survey, right? When you complete your next survey, and then you'll say, hey, they decided to put the 5 first, huh? And something like that. So anyways, so these numbers are just placeholders for these categories, okay? And even if there aren't distinct categories for the numbers can still be categories, so that gets confusing. But for example, if I'm only interested in, let's say, predicting who will strongly agree with a statement, okay, then I would call this my target, right? And then, so the thing that I'm interested in would be all the 5s, okay? So what I could do is I could think of it as, okay, this is a 5, and these are not 5s, right? So if we are interested in predicting who would answer strongly agree, in predicting who would answer strongly agree, right? We would make the 5 category our target, okay? And so we would make the 5 category our target. Okay. So what we could do is we could boil this down and we could say, okay, well then these are not 5. And this one is 5. So all the not 5s would be coded as zeros, right? They're not 5. And if they answered 5, they get to be a 1. Okay? And so we always just kind of pull out the one that we're interested in. So you can only pick one target, we're going to call it. Or what we could call it a response variable, but gets a little bit confusing because these are all responses, right? All these outcomes. But now that we have this kind of target outcome that we're trying to predict, so we want to focus on the prediction of the strongly agree or strongly disagree. Usually we wouldn't care about who answers neutral, right? Because that's not interesting, right? And so other things we could do is we could lump 1, 2, and 3 together and lump 4 and 5 together, and we can play around and see if we get different results. And if we do get different results, we'd have to take that into consideration, right? And so there's obviously a lot that goes into it, and a lot of it is just, practice. But just some things to keep in mind. So any categorical variable can be turned into a binary variable. As long as we have that target outcome, then it either is that target outcome or it is not that target outcome, right? And so if we think about, eye color, for example, either you have brown eyes or you don't, right? And so even though there are other eye colors, right, if we're interested in brown eyes, then that would be a 1, and then anything else would be a 0, right? And we do that a lot already with categorical variables, maybe we have an other category, which is kind of a lump of the other things that can happen, right? If they're kind of rare, then we use that other category. So, all right. So any categorical variable can be converted to a binary variable, right? That's something that we need to keep in mind. Okay. So let's see here. Where did I say? Oh yeah. So here, right, the binary data is going to be a focus for us. And that's because for categorical data, if we have some target outcome, then we can convert categorical data to binary, and then we can focus on that, right? That doesn't mean that's always what we're going to do, but it's often what we're going to do, and it's what we're going to have the tools to do. So one thing that we assume is that we have what we call rectangular data. Okay, so data as we are familiar with it is rectangular data. So when we think of data, we think of what we call rectangular data. We think of rectangular data. Okay. So something like this, right, where we have a spreadsheet and it forms this rectangle. It could be a square, but let's say a rectangle just to be general about it, of course. Pretty rare that you have a square. Right, and so, but we think of a spreadsheet and, going back to Excel, if you open up your data, then you expect it to be in this rectangular format, okay? And so that's not always the case, but it is what we're gonna assume for this textbook, okay? So in data science, that's not always the case, but it is often the case. So you'll be handed a rectangular data set, and that's why we're gonna stick to that. Okay, so a rectangular data set, I'll just extend it a little bit more here, has the records or the cases for the rows, and it has the columns are going to be called features now, whereas we used to call them variables. Okay. So that's kind of one big change that we're making, is that we're going to call these features and records, okay, as opposed to cases or observations and variables. Okay. And so features is specific for data science, and it's because you're often talking to a client, and when you say features, such as, age and height and weight and, other variables that you could talk about, instead of, talking about variables, because as you might remember, saying and hearing variables makes it a little bit scary for some reason. And so then when you say features just kind of gets you thinking on a different path, right? So some features that we saw are that the average age was 30, and the 40% were smokers, and I don't know, just kind of examples like that. So for features, think about describing your data instead of describing variables, now we're going to be describing features, and it just kind of sparks something. I don't know, describing, think about describing features such as the average age was 30, 40% were smokers. I don't know where I'm getting this data from, but that kind of thing, right? This example, kind of straight from my head, from me to you. So, so as soon as we say features, right, then it kind of, okay, yeah, sure, these are features of my data, right? And so we're going to assume that we have rectangular data, right? And there are methods for dealing with non-rectangular data, but we're not going to deal with them. So in this course, we will assume we have rectangular data. Rectangular data. Okay. There are methods, of course, for dealing with non-rectangular data, but most things that we encounter just are based off of rectangular data. Non-rectangular data is possible. Oops, data. Data is possible, but we will not consider it here. So one of the things, if you are faced with non-rectangular data, then, and it could be, you know, text, so comment boxes, things like that. There are ways to deal with that. But ultimately, what you're going to work towards is making that non-rectangular data rectangular, and then you can deal with it, right? And so even if that's not possible, there are ways to deal with it, but that's not for us. Okay. Okay. So when we say a rectangular data set, what we're going to call that in R and in Python is a data frame. Okay. And so a data frame is just a specific data set that is rectangular. Okay. So I'll just add that up here. So in R and Python, this is called a data frame. Right, because it's got this nice frame, okay, but it's talking about rectangular data. And like I said, that's going to be the default, so it's not something you need to concern yourself with, but it's just good to have the terminology. Okay, so in data science, usually what we're going to be doing is we're going to be predicting things, right? We want to look at data and we want to predict what's happening, and we need to rely a little bit on statistics where the emphasis is, okay, based off of the variability here, what can I conclude, right? What's going on with the population that I took this sample from? That's going to change a little bit, where for data science, we're typically only concerned with kind of what's happening in here, right? How can I use what's in my data set to predict what's going to happen in the future, right? And so, and when I say future, I don't always mean time-wise. I mean, if I collected other data, what should I expect to see, right? And so, yeah, future data doesn't always mean time, but it can. Just context, which makes it tricky. Okay, but so we will often want to want to predict an outcome or a target. Want to predict an outcome or target. Okay, so predictions are going to be something that we emphasize. Okay, and so we've been calling them response variables, right? And so here we could call them response variables. Okay, but now we're going to start calling them outcomes or targets. Okay. Usually the outcome, we would use outcome for numerical data and target for categorical data. I'm not going to specify that here, but that's kind of in my mind how I would use the two, right? And so more for numerical data and more for categorical data. But they mean the same thing, and you can use them interchangeably, but how I would use them is the outcome is for a numerical variable, and a target would be kind of the target category, like we talked about. If my target category is who answers 5, right? Who answers strongly agree? How can I find those people so they can give me a review? That's good, right? That happens. Okay. And so then it would be more of a target. So we're going to predict outcomes or targets. And what we're going to do is we're going to use features to do those predictions. Features are used to predict the outcome. To predict the outcome or target. So that's where we would have called those explanatory variables, right? Just to kind of make the connection here. But specifically to data science, we're going to use features and target and outcome. And so we're just kind of morphing our terminology. Okay. Features are all the things that we take into account in order to predict an outcome, right? So a feature such as the this age group or this income bracket and that kind of thing, that's what we use to predict the outcome. And we've called them explanatory variables. We could also call them input variables or predictors, which kind of gets confusing because we're trying to predict, but we use predictors to predict. And I'm thinking specifically of regression because that's the only example that we've seen so far where we actually make predictions. And so for linear regression, right, I have an X variable. And so then I'm considering one feature to predict my Y, which is going to be my outcome or my target. Okay. Okay. So let's see here. Once we have our data and we've kind of split our variables into different types, numeric and categorical, and then if we have categorical data, do we have binary or do we have ordinal data that we need to take into account? Then we can start talking about estimates of location. So first thing we talk about is center. Remember, if we have a distribution of a numerical variable, Then we look at the histogram and we describe the distribution. So now we're going to do the same thing. We're going to talk about numerical measures of center. Okay. And so the estimates of location are really just numerical measures of center, right? So measures of center is what I would have called it in Stat 230, and pretty common that we call it that. Okay, but now we're going to morph into calling it location. So where is this data centered, right? And so some common estimates of location or measures of center that we talk about are the mean, the median. We can also talk about the mode, which I tend to ignore, and we're going to introduce the mode more for categorical data. But in Stat 230, we don't really talk about categorical data that much. And so kind of parking lot at it. But so some estimates of location are the mean, the mean, the median, and then I'm going to put the mode in brackets here. And I'm going to say used more for categorical data. And these are probably the ones that you have seen and remember, right? And so the mean is the average, right? So we can talk about the average. And the median is the central value after sorting. So those are the ones that we focus on in an introductory course, right? That's plenty. We talk about the mean, we talk about the median, and of course, we're talking about numerical data here, or numeric data. So what we're going to introduce now, right? And so these are kind of the most kind of the intro stats measures that we use. So now I want to talk about a couple more, because we need to have a good handle on what all these are. Okay. And so we can talk about the weighted mean. The weighted mean is when each value is assigned some weight. Okay, it's user assigned, so I would determine what that weight should be, and maybe there are some outcomes that are less reliable than others, so then I would want to weight them a little bit less than the more reliable outcomes, right? And so then I could kind of shift my weight. Now your grade is a weighted mean, right? Your assignments are worth less than your I don't know, your tests, for example, and then your final exam is worth the most, right? And so, but it is just a weighted mean, right? And so the weighted mean is each value is assigned a weight. Okay. And then we take the average. Then take the average. And of course, we're going to use software to do it. So I'm not actually going to introduce any of the formulas. However, what I want you to do when you're reading the textbook is I want you to look at those formulas and just kind of convince yourself that they make sense. They're not something worth memorizing or anything like that. But what I want for you to do is to kind of make the connection between looking at that formula and saying, okay, I see the formula. I understand what I need to do based off of the formula, right? Because that's where we kind of should be getting to, right? If I give you the formula, here's how it works, then you need to be able to read that formula and understand, okay, the weighted mean, I assign some weight to each of the values, and they might not be the same weights. Usually they're not. If they are, that doesn't make sense, right? That's just the average. But right, so you should be able to look at a formula and kind of make the connection. What's the next one I want to talk about? The percentile. We have talked about percentiles in Stat 230. Or intro stats, let's call it. So a percentile is, you've got sorted data, right? And it's the value that has the lowest percent of that percentage below it and 1 minus that percentile above it. Okay, and so the percentile is the pth percentile has p% of the data below it and 100 minus p% above it. Okay, so data is sorted. We're going to call that ordered data. Okay, when we need to sort the data before we can do any calculations, then we call it ordered data. So for example, the mean, we don't have to have sorted data, right? Whereas for the median, we have to have sorted. I'm combining ordered and sorted. We have to have sorted data. Okay, and so here, after sorting, sorted, one thing, yeah, just combining words. So one thing that gets tricky, if we have a huge data set, then sorting can be computationally expensive, right? So that's one thing to keep in mind, is if we're relying on sorted data, then all of a sudden it might become tedious, right? So then taking the average, where we just add up all the things, instead of having to sort them first and then doing our finding the median or finding the percentile, the median is a percentile, right? Then it might be better, right? It might be easier, computationally easier. Now, of course, we're used to computers and we're used to having all that computing power and, oh, who cares? But if you're talking about, you know, if Google decides to sort one of its variables, that could take a long time, right? If you ask a computer to sort, so Google has this, you know, huge data set, I'm sure of it, and I'm sure it's all relational databases and blah, 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 blah. But if you consider just one of their variables and you ask to sort it, it would take a long time, right? So that's what we have to be kind of cognizant of. Okay, so the percentile, so note the median is the 50th percentile. Oops. Right? Because it has 50% of the data below it and 50% above it, right? 100 minus 50 above it. And then, so we've already seen some specific percentiles, and those are the quartiles, right? And so the quartiles are specific percentiles, right? The 25th percentile is the first, is the first quartile. Q1, we usually call it. Oops. Right? The 75th percentile. Is the third quartile. Right? When we talk about the 1%, right? So sometimes, especially on TV and stuff, they'll talk about the 1%ers, right? And so that would be the top 1% of the data, right? Which would actually be the 99th percentile, right? And so and the time where we really talk about percentiles is I think for babies, right? We talk about baby weights, baby heights, kind of brain development. All those would be measured on percentiles, right? And so we're kind of used to percentiles. It's just this idea of, okay, first you have to sort your data, and then you break it up into percentiles. Right? And we're not going to do it by hand, although we all love the boop, 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 boop method. We're beyond that, right? But that is what's going on. First, we have to sort our data, and then it goes in and it finds the values. Of course, there's fancier ways to do it, right? Finding the location of the percentile and then going to find it. But the idea is there, right? The boop, boop, boop method still applies, but we can't use it anymore because our data is going to be too large. Okay, so we've seen a lot of percentiles already, right? We just didn't call them percentiles necessarily. Okay. I'm just realizing here, I didn't actually say what the mode was, but the mode is the peak of the distribution. And so the mode is the peak of the distribution. So the reason that we don't really use it for numerical data is because, well, our sample, if we're looking at a sample, it would be slightly different if we collected a new sample, right? And so then the mode would change just slightly. Whereas for categorical data, if we talk about the category with the highest count in it, that would be the mode. And so that makes more sense to talk about. Okay, so the percentile, just like the weighted mean, we can also talk about the weighted median. But again, it's a little bit tricky because we still have to sort our data, right? So the weighted median it makes sure that the 50% of the lowest weights are on one side of the median and 50% of the highest weights. So it splits the weights in half. Okay. Splits the sorted data in half based on the weights. Okay. So again, we're talking about sorted data. And of course, the weighted median, you have to assign the weights, and that can be hard to decide, right? How do I decide what the weights should be? So that can be tricky. So it's not something that we're going to dive into right away. But the last measurement that I want to talk about is the trimmed mean. Oh, what I was going to finish saying there was that it is something that we can do. And so that's why I wanted to introduce it. So the trimmed mean, what does that do? It does find the mean, but it trims off some number of observations on either side. So on the maximum and the minimum end, we can take away, you know, some percentage. So 10% of the data on either side is kind of typical. So we trim down the data and we only focus on the central 20%, sorry, 80%, trimmed off 10% on either end, right? And so we trim or drop a fixed number of observations from either end of the data. That does require that it's sorted again, right? Sort of. You could go through and you could find the smallest, right? Finding the minimum and finding the maximum is easier. And then you can move in from there. So you don't necessarily have to sort it, but it does make it easier. And that's kind of typically what's done. But oh yeah, so why do we do this? Okay, so the reason that we use the trimmed mean is because the trimmed mean, if we go back, take a step back, the reason we use the median is because it's robust to outliers. So the mean takes into account all the values, and then we find the average of those values. Whereas the median is robust to outliers. You can have crazy things going on in the tails and it still doesn't matter. It finds the center. We don't love that idea because it's still just one value, right? We end up at the one value and it doesn't take into account anything else that's going on, which is sometimes good, sometimes not that good. So the reason we use the trimmed mean is because now we take away those potential outliers, and then we can still use a lot of the data to find the mean, right? And so here, maybe I'll say by removing potential outliers from the calculation, so by removing potential outliers from the calculation, we can have a robust estimate. We get a robust estimate that incorporates more of the data than just the median, which only looks at one value and ignores the rest. So we get a robust estimate that incorporates more data as opposed to the median, which is also robust, but it also only considers one data point, if that, maybe the average of 2 data points, right? Remember how we find the median, but it ignores all the other data. But it only considers, let's see here if what I'm saying makes sense. By removing potential outliers from the calculation, we get a robust estimate that incorporates more data as opposed to the median, which is also robust, but it only considers 1 or 2 data points and ignores the rest. There are times where we're okay with that, right? But sometimes we want to have more of our data in this estimate. Okay, so robust the term robust means robust to outliers. So it can handle outliers, right? Means it isn't swayed by outliers. Yeah, so it's resistant to outliers or it's robust. So usually we call it robust, but I might have said it's resistant to outliers. It can kind of handle these extreme values and it would still kind of hold steady. Okay. And then one thing that I want to highlight is that usually in statistics, we would call these all estimates, right? We estimate them based off of our data, but now we're going to start calling these metrics. Okay? So just as my final note here, in statistics, we call these measurements estimates. Whereas in data science, we will call these metrics. We call these metrics. Right, so metrics like the mean, the median, the trimmed mean, oops, etc. Those are all metrics. And I think that makes it a little bit more clear because if you hear the term metrics, it's, I don't know about you, but for me, I'm kind of like, whoa, I don't know what you're talking about, right? But we're really just talking about these same measurements, but now we're calling them metrics. Okay. I just want to make sure that I'm not out to lunch here on my time. No. Okay, I am out of time. I thought I was. I just had to make sure. So we'll leave it there and we'll keep talking about chapter 1. So I encourage you to read it, but also read chapter 2 for next week. And we'll do a video for lab 2 where we'll introduce some of the R code and Python code for calculating these things. If you have any questions, let me know. Otherwise, I hope you have a great weekend and I'll see you next week. Stop this.